Today we are going to be doing masked word prediction using transformer models. You may have heard of various transformer models like BERT, XLNET, and RoBERTa. You don't have to know much about these models other than they are large language models mainly produced by large tech companies like Facebook AI and Google AI that have many different applications. And the most common way to interface with these models is to use PyTorch's transformer library, which as you can see is very popular. This is a great way to do it. However, it requires some technical understanding. If you look at their documentation and if you are new to AI, you might become confused quite easily, and it would be pretty time consuming to learn all of this. So my team over at QMind, which is the Queen's University Artificial Intelligence Hub, created a library called HappyTransformer, which is essentially a wrapper built on top of PyTorch's transformer library that makes it easy to utilize state-of-the-art NLP models. So that's what I'll be showing you how to use today. In just a few lines of code, we'll be able to do masked word prediction. First off, we have to pip install the library. I'm using Google Colab right now, which is a web interface that all of you can easily access. So to do so, I simply have to type the command into one of these cells, pip install HappyTransformer. If some of you are using other editors like PyCharm, then you'll have to type this into the terminal. There we go. So HappyTransformer is now installed. Now let's import it. Of course, we could just import it like this, HappyTransformer. That will import everything, but we only want to use a specific HappyTransformer. So you could decide which one you want to use. For the sake of the tutorial, I'll be using RoBERTa since it is the best for masked word prediction. So we could copy that right there. So to do that, we do from HappyTransformer import RoBERTa. Now that we have imported the RoBERTa class, we want to initialize a RoBERTa object. So a suiting name for this object would be RoBERTa, like so, with an underscore. And we want to use this imported class to initialize it. So to do so, we simply do this. And now by default, the HappyTransformer library uses the base version of all of the imported transformer classes. So in that case, just by using default settings, it would be the RoBERTa base version. However, the creators of RoBERTa also released a RoBERTa large version, which is much better for masked word prediction, and we will be using that one. Now let's do an example using this RoBERTa object to predict a mask within the sentence. So we need a sentence that contains a masked token. So the sentence could be something simple. Let me think of one quickly. AI will cause world mask. There we go. This is a good sentence, and our RoBERTa object has the ability to produce predictions for this masked token, this masked word, which is simply a string within the sentence. And this mask could be anywhere. It doesn't necessarily have to be within the end. It could be here, it could be there, but there could only be one at a time. So let's get the string back to how it was with it at the end. Now we could simply use this object to produce a prediction. And by doing so, we will produce results. So results equals RoBERTa dot predict masked. And predict mask is the public method that we will be using for this task. And it contains 3 arguments, which I'll be getting to shortly. But at the start, let's just use default settings to produce these results and print what the results look like. So right here, it is initializing the transformer model. It only has to do this the first time you run it for predict mask. Then it will save it into memory, so it doesn't have to initialize it again. So now we wait. After a couple of minutes or so, you will be prompted with the results right here. And there we go. So the first prediction was war. So AI will cause world war. That's a surprising result. Let's see what the other options are. Hopefully they are a little more joyful. So let's look at the top 5 results. If we print it, you'll see that it loaded quickly this time because it already saved the model into memory. So the first result was war with a very high softmax. And for those of you who don't know, you could think of softmax as a kind of probability, because if you were to add up all the softmaxes, you would get the number 1. So by multiplying this value by 100, you essentially get the probability, which is an easy way to think about it. So the first result was war, followed by wars, followed by hunger, oh, and then peace, I like that one, and destruction. So it looks like this HappyRoBERTa object does not have a very nice view on how AI will change the world. So moving on, let's say we just wanted to get good news from this model. We just wanted to get the word peace, or this prediction peace. What would we do? Well, we could see that we are currently returning a list. If we run this, see it's a list. So it's a list of dictionaries. If we want the word peace, peace is the first, second, third, is the 4th index within this prediction. So we could do print results 3, of course, because this list is 0 indexed. It starts at 0, and that will give us this prediction right here. Let's just isolate it to make it clear. There we go. So we have the prediction piece, and we have this softmax. And from here, if we only want the word, we don't care about the softmax, we could simply do this. Since it's a dictionary, and we're just accessing a value within the dictionary. We're accessing the word value. When we do that, we get the word peace. And of course, if you only care about the first result, you could do that and get the first result. Just want to point out that the predict mask method can be used with more than a single sentence, so let's demonstrate that. First off, let's rename the input variable to text to better represent it. Then let's extend this sentence. So we could add something like, then AI will end hunger. Okay, maybe that should work. And there we go. The top result is peace. If we want to get more than just the first result, we could do this. And it looks like peace was predicted with high certainty, 41%. So AI will cause world peace, then AI will end hunger. That sounds about right. Its second choice is hunger, just repeating this word here. And then some more negative ones were the later predictions, but it looks like its top result seems to make sense. And I just want to add that we will be covering example 2 in a future video. And then after a few more basic examples, we will tackle interesting use cases that are similar to talk to transformer, where you could type in the start of a sentence and the transformer models will finish it.